Pluto, once considered the ninth planet in our solar system, continues to fascinate scientists and people around the world. Since its discovery in 1930, Pluto has remained a mysterious world, far away, leaving us intrigued. Perhaps that's why it was named after Hades, the god of the underworld. In 2015, the New Horizons mission made history with its close flyby of Pluto, giving us our first detailed look at this distant planet. What it revealed was astonishing. Vast glaciers, towering mountains, and a hazy atmosphere. A dynamic and complex world that only deepened Pluto's mystery. But as we've uncovered more about Pluto, one question keeps coming up. Could there be hidden life beneath its icy surface? At first glance, it seems like Pluto would be the last place to support life. The temperatures here are extremely cold, reaching nearly -225 degrees Celsius. It's so far from the sun that it only gets a tiny fraction of the sunlight that Earth receives. And yet, recent discoveries have sparked excitement among scientists. They believe that beneath Pluto's frozen surface, the essential ingredients for life might be hiding. In today's video, we'll explore the possibility of hidden life on Pluto. We'll look into the conditions of this dwarf planet, the surprising discoveries made by the New Horizons mission, and the potential for life in extreme environments. Could Pluto, despite all its limitations, harbor some form of life? Let's take a journey into the unknown and unravel the mysteries of this distant world. The conditions on Pluto. To understand the potential for life on Pluto, we first need to take a closer look at the conditions on this distant dwarf planet. Pluto is located in the Kuiper belt, a region beyond Neptune filled with icy bodies and remnants from the early solar system. It's a frozen world with a surface primarily made up of nitrogen ice, along with traces of methane, carbon monoxide, and water ice. The surface temperature on Pluto is one of the coldest in the solar system, hovering around -225 degrees Celsius. Because of these extreme cold conditions, all the water on its surface is frozen solid, making it seem like an unlikely place for life to exist. However, recent discoveries suggest that Pluto may not be as inhospitable as it first appears. One of the most surprising findings came from NASA's New Horizons mission, which uncovered something that made scientists stop and think. A subsurface ocean beneath Pluto's icy crust. Evidence of this hidden ocean was discovered in a surface feature called Sputnik Planitia, a massive, heart-shaped area. This region is known for its giant ice sheet made of nitrogen and methane. The smooth, crater-free surface suggests that this area was likely shaped by recent geological activity on Pluto. Scientists believe that the presence of this subsurface ocean could help explain some of the features we see on Pluto's surface. For example, the cracks and ridges in Pluto's icy shell could have formed as the ocean gradually froze and expanded. Additionally, New Horizons detected hints of ammonia on Pluto's surface, which could be another clue pointing to a liquid ocean beneath. Ammonia acts like antifreeze, lowering the freezing point of water. This means that even at these extreme temperatures, there could still be hidden reservoirs of liquid water on Pluto. If Pluto really does have a subsurface ocean, it could be a potential habitat for life. Just like on Earth, life can thrive in extreme environments. We've seen organisms living around deep-sea hydrothermal vents, where they survive without sunlight, relying on chemical energy instead. Perhaps Pluto has similar conditions, where life could be thriving beneath the ice, depending on chemical reactions and geothermal energy from the ocean below. Evidence of geological activity. Another surprising discovery from the New Horizons mission was evidence of ongoing geological activity on Pluto. Before the flyby, scientists thought Pluto would be a cold, dead world with little to no geological activity. But the landscapes we observed during the mission completely challenged those expectations. Pluto's surface is filled with a variety of terrains, including vast plains, towering mountains, and deep valleys. One of the most striking features is Sputnik Planitia, a massive heart-shaped region made up mostly of nitrogen ice. The surface here looks surprisingly young, with very few impact craters, suggesting that Sputnik Planitia is constantly resurfacing, possibly due to convection currents in the subsurface ice. Another piece of evidence for geological activity comes from Pluto's mountains. Mountains made primarily of water ice. These mountains rise up to 3,500 meters, comparable to the Rocky Mountains here on Earth. The presence of such large mountains indicates that Pluto's crust is made of strong, rigid water ice, capable of supporting massive structures like these. The combination of water, ice mountains, and nitrogen ice plains on Pluto suggests a complex and active geology. But the question is, what could be driving these activities? One strange possibility is heat generated by radioactive decay happening deep within Pluto's core. When radioactive elements break down, they release heat, which could potentially be enough to maintain a subsurface ocean and drive geological activity on Pluto's surface. Another intriguing possibility is cryovolcanism, ice volcanoes. Unlike traditional volcanoes on Earth, which erupt molten rock, cryovolcanoes would erupt water, ammonia, or methane. During the New Horizons flyby, scientists spotted large dome-like structures on Pluto's surface that could potentially be cryovolcanoes. If this is true, it would provide even more evidence for a subsurface ocean and suggest that liquid water, mixed with other chemicals, could be reaching Pluto's surface. This discovery of active geology on Pluto opens up the exciting possibility that this distant dwarf planet might actually provide conditions necessary for life. On Earth, geological activities play a crucial role in supporting life, recycling nutrients and providing energy sources like hydrothermal vents. If similar processes are happening on Pluto, it could create habitable environments beneath its icy surface. The potential for life in extreme environments. The discovery of a possible subsurface ocean and ongoing geological activity on Pluto raises an exciting question. Could life exist on Pluto in such an extreme environment? To answer this, we need to look at what we know about life in Earth's extreme environments. On Earth, there are places that seem completely barren, where conditions for life appear almost impossible. Yet, life manages to survive in these harsh environments. Take deep-sea hydrothermal vents, for example. These underwater ecosystems thrive without sunlight, relying instead on chemical energy coming from the Earth's interior. These ecosystems are based on chemosynthesis, a process where bacteria convert chemical compounds like hydrogen sulfide into energy, providing a food source for other organisms. Similarly, life has been found beneath Antarctica's ice shelves, in icy waters, in acidic hot springs, and even deep within underground rocks. Organisms that can survive in these extreme conditions are called extremophiles. This shows that life can adapt to a wide range of environments, many of which once seemed impossible for survival. If life can thrive in these extreme Earth environments, it's conceivable that similar forms of life could exist on Pluto. If there is indeed a subsurface ocean, it could provide a stable environment for life to develop. Whether the ocean is extremely cold or completely dark, life could still survive by relying on chemical reactions for energy, just like Earth's extremophiles. Additionally, the presence of ammonia and other complex molecules on Pluto suggests that its ocean might contain the building blocks for life. On Earth, ammonia plays a crucial role in the formation of amino acids, which are the building blocks of proteins. If similar chemical processes are occurring on Pluto, it could increase the possibility of life existing there. However, it's important to note that while Pluto's conditions might support life, we have yet to find any direct evidence of life there. Subsurface oceans and geological activity are intriguing clues, but they are not proof. To truly understand whether life exists in Pluto's hidden ocean, we will need further exploration and study. Future missions and exploration. The discoveries made by the New Horizons mission have fundamentally changed our understanding of Pluto and raised new questions about the potential for life on this distant world. To answer these questions, future missions to Pluto will be crucial. One exciting proposed project for Pluto is a sample return mission, which would include an orbiter and a lander. The orbiter would give scientists the opportunity to study Pluto in even greater detail, mapping its surface, analyzing its atmosphere, and searching for signs of geological activity. The lander would provide direct measurements of Pluto's surface and subsurface, potentially helping us detect a subsurface ocean or life-supporting features. Another mission concept for Pluto involves sending a probe to study its atmosphere and surface chemistry. Using advanced instruments, this mission would analyze the composition of Pluto's surface and atmosphere, looking for organic molecules and other compounds that could indicate the presence of life. Beyond Pluto-specific missions, future explorations of the Kuiper belt, where Pluto resides, could uncover new possibilities for life in this distant region of the solar system. The Kuiper belt contains many icy bodies that are similar to Pluto. By studying these objects, scientists can better understand the processes that shape their surfaces and interiors, as well as their potential habitability. In 2019, NASA's New Horizons mission flew by another Kuiper belt object, Arakoth, previously known as 2014 MU69, revealing its unique shape and surface features. This provided valuable insights into the early history of our solar system. Future missions may uncover even more surprising discoveries about the Kuiper belt and its potential for life. Although no missions to Pluto or the Kuiper belt are currently scheduled, scientific interest in these distant worlds continues to grow following New Horizons. With advancing technology and the expanding field of space exploration, the likelihood of returning to Pluto in the coming decades is high. New Horizons left many mysteries unsolved, and to answer them, we'll need to return. Our journey to Pluto will continue to inspire and challenge us. Pluto is a world full of surprises. What we once thought to be a cold, dead planet is now showing itself to be a dynamic and active place, challenging our previous assumptions. Our discoveries are forcing us to reconsider, as Pluto might just have the essential ingredients for life. While we haven't found direct evidence of life on Pluto yet, the possibility challenges our understanding of the potential for life in such extreme conditions. This is why Pluto will remain a priority in future exploration. With new missions and advancing technologies, we'll have more opportunities to learn about this distant world and maybe even uncover clues to its potential for life. The mysteries of Pluto remain unsolved, and the journey to uncover them has only just begun. What do you think about this topic? Feel free to share your thoughts in the comments section. If you liked this video, don't forget to like it and share it with your friends. For more informative videos, subscribe to our channel and hit the notification bell so you don't miss out on any deep dives into space exploration and scientific discoveries. We'll see you soon with another exciting video. Until then, stay curious.